Hello and welcome to this video on what is a CTCM-1 model. My name is Geiser, I'm an instructor with QuantFish. So in this video I want to shed more light on a specific model of confirmatory factor analysis that is often used to analyze multi-rater or more generally multi-trait, multi-method data, and that is the so-called CTCM-1 model. First of all, what does CTCM-1 stand for? It stands for correlated traits, correlated methods -1. And we will see shortly why it is called that. So those are the components of this model, as we will see. When was this model first introduced? It was introduced by Michael Eid in the journal Psychometrica in 2000. And what was the reason for developing this model? The reason was that other methods, other confirmatory factor analysis models for multi-trait, multi-method data showed a number of problems that made their use in practice complicated and often prone to errors and interpretation issues. And so Michael Eid came up with this alternative model for modeling multi-trait, multi-method data. So let's take a look at what the CTCM-1 model looks like. And so we'll start slow, variable by variable. And so imagine you have a design where you're measuring anxiety, for example, by self-report. So you have a self-report measure of anxiety, for example, an anxiety questionnaire that individuals fill out to rate their own level of anxiety. And then in addition to that, you maybe also collect a parent report of anxiety because you're not sure that the self-report is entirely valid or reliable or useful. For example, if you're looking to measure anxiety in small children, then perhaps a self-report measure isn't the best choice, or maybe it won't give you all of the information that you might like to have. And so you also collect a parent report, and perhaps you also collect peer ratings of that or those children's anxiety. So you have three different sources of information to measure anxiety in children: a self-report, a parent report from those children, and also a peer report. And then obviously, in terms of confirmatory factor analysis, we may assume that these three measures are reflective of a common trait factor, here labeled as T1, which would be our anxiety factor. And now in multi-trait, multi-method design or multi-rater design, we typically have more than one trait. We may have only one, and that could be fine. However, for the CTCM-1 model, we need to have a little bit more than just one trait for the model to work and be identified. So in this situation here, in this example, I have a second trait, extraversion, and extraversion is also measured by the same three types of reporters: self-report, parent report, and peer report. And so we have a second factor then, T2, extraversion. And we have a third factor here as well for measures of happiness. Again, self-reported happiness, parent-reported happiness, and peer-reported happiness of the same children. So this would be a design with three traits. And we could have more than three traits as well. The trait factors in this model can all be correlated, and here you can see why it's called a correlated traits model, because the traits that we're measuring here are allowed to correlate. So far, this is just a simple model of confirmatory factor analysis, nothing special. However, since we have a design with multiple raters, we typically do not only have effects of common traits, and in fact, the effect of common trait variance may be rather small in many situations when you have a multi-rater design, but we may also have method effects or rater effects, and those can actually often be quite strong. So we need to account for common method effects as well. Where do the common method effects come from? They come from the fact that we have parent reports that of the three traits that may be more highly correlated with one another than with other reports, such as self-reports or peer reports. And the same is true also for the other methods. So self-reports may be more similar to one another regardless of the trait, and also peer reports may be more similar, reflecting so-called halo effects, for example, where a person rates other people high on everything. So that often happens due to halo effects, where a general impression of a person or a child influences how different traits are being assessed. So for example, somebody who rates a child's extroversion as high may also report that child's happiness as high, because they have a general positive impression of that child. So they may rate extroversion high, happiness high, anxiety low, even though there may be nuances in those traits where it's actually maybe not so highly correlated. So those are rater effects, halo effects, shared method variance, and they also need to be taken into account in the model. And therefore, in this model, we are selecting one method as reference, for example, the self-report, because when it comes to measuring psychological traits and feelings, emotions, oftentimes individuals themselves have the most access to those. For example, a child themselves may know best whether they're anxious or not. It may be not as visible to parents and peers. And so we may choose the self-report as our reference method. For the reference method, we do not include a method factor, because that is used as our gold standard, or as the reference that defines what the traits mean or how the traits are best measured. Now, the self-report in this case may not be the best choice. Perhaps parent reports would be more valid, especially with younger children. So this is something that the researcher has to decide based on theoretical and substantive and or empirical reasons. There may be reasons why a certain measure would be used as the gold standard. Maybe this is a measure that has already been validated a great deal, or that's an established measure that people use all the time in a given field, or there may be other reasons why we think that a specific method might be a good gold standard. So here I'm just simply assuming that self-report is chosen as reference method for the sake of presentation, and then the other methods are our non-reference raters or non-reference methods. So the parent report is a non-reference method, and so parent report gets a method factor in addition to the variables loading onto the respective trait factors. So here you have a method factor M2, which loads all the parent report variables. And we also have a peer report method factor M3 that accounts for shared method variance across the different peer report variables. The method factors are allowed to correlate, and that's why it's called correlated traits, correlated methods -1 model, because traits and method factors are allowed to correlate, and there's one method factor less than we have methods or raters. So here we have 3 methods: self-report, parent report, peer report, but we only have 2 method factors. And so that's the correlated traits, correlated methods -1 model in its single indicator form. There's one thing that I forgot to mention, and those are that there are also measurement error variables, as is common in factor analysis models, that we also account for random measurement error, and that's reflected in the epsilon variables here that are accounting for measurement error. Now, one nice thing about the CTCM-1 model is that it allows us to decompose the variance of the non-reference indicators into trait variance, lambda squared variance t, and method variance, which is delta squared times variance m, plus measurement error variance. And those variance components are independent because trait and method factors are uncorrelated, and trait and method factors are also uncorrelated with the error variables in this model. And so as a result, we can define coefficients to partition the variance or proportion of explained variance. Those coefficients are R-squared type measures that allow us to quantify the proportion of variance that is shared with the reference method. That's the consistency coefficient, CO. So that indicates what proportion of the observed variance in a given measure, for example, this parent report measure of extraversion is shared with the self-report of extraversion. So that would indicate convergent validity in the sense of Campbell and Fisk's multi-trait, multi-method matrix approach. So we can measure convergent validity relative to the reference method, here self-report. We can also measure method specificity, which is given as the variance that is accounted for by the method factor over total variance. And so that gives us the proportion of variance that is unique to a given method or rater type and not shared with the reference method. So for example, the amount of unique variance that is reliable but not shared with the self-report for extraversion in parent reports of extraversion. So method specificity can also be quantified, and then we can see whether a measure is high in convergent validity if it has a high consistency coefficient, or if it is high in method specificity if it has a high method specificity coefficient. Obviously, it's more desirable for measures to have high consistency and low method specificity, because that would indicate that there is a high degree of convergent validity relative to the reference method. And then finally, we can also determine the reliability coefficient in the sense of classical test theory. Reliability is given as the sum of consistency plus method specificity. Those are two systematic sources of variance that are due to common factors. And so those are both contributing to the reliability of an indicator in the sense of classical test theory. Another thing that we can determine with the CTCM-1 model is discriminant validity. Discriminant validity can be examined by looking at the trait correlations, so how highly the trait factors for anxiety, extraversion, and happiness are correlated. That's an indicator of discriminant validity with regard to the reference method. Now, the single indicator CTCM-1 model has one limitation, and that is that it assumes that method effects generalize perfectly across different traits. So we're assuming, for example, that the parent report rater effect for anxiety generalizes perfectly or is perfectly correlated with the parent report method effect for extraversion and for happiness. And that may not be the case, because method effects may be stronger or may be different for anxiety as opposed to extraversion. Extraversion would be easier to observe for an external rater than would be anxiety, and so therefore method effects may not generalize perfectly across traits. And in fact, I have a paper out in the Journal of Personality where we show this, that method effects tend to not generalize perfectly across raters. In fact, they're often quite trait specific. So for different traits, we find rater effects that are not necessarily super highly correlated. So you can check out that paper. It's in the description, the reference, you can find it there. So therefore, a different version of the CTCM-1 model has also been developed by Eid and colleagues, which is called a multiple indicator CTCM-1 model, and that model tends to be more realistic in practice and tends to fit better. It does not assume that method effects generalize perfectly across traits. In the multiple indicator CTCM-1 model, we have more than one observed variable per trait method combination. So for example, here we have two traits so that this model would fit on the slide, and so this could again be anxiety and extraversion. Trait 1 may be anxiety, and now you can see we have 3 indicators for anxiety for self-report, 3 indicators for anxiety parent report, and 3 indicators for anxiety peer report, and the same for extraversion. So there are 3 indicators per trait method combination, and that allows us to specify trait-specific method factors. So now we have, for example, a method factor M12, which characterizes the method effect for parent reports as they apply to anxiety only. And we have also an anxiety-specific method factor for peer reports, which would be M13. Likewise, we have a trait-specific method factor for parent report parent reports of extraversion, which would be M22, and a trait-specific method factor for peer reports of extraversion, which is M23. And so those method factors, again, can be correlated, and those correlations would tell us something about the extent to which method effects generalize across different traits, and also the extent to which method effects generalize across raters. So whether, for example, parent and peer reports of extraversion share something in common above and beyond what they share with the self-report. So this model is a lot more general, a lot more realistic and applicable, which is why we prefer a model like this in practice. Of course, it requires you to have multiple indicators per trait method combination. However, we often have that anyway because we usually use multiple item scales. So we have multiple items for anxiety, we have multiple items for extraversion, and so then we can do the analysis at the item level, or we can use item parcels or test halves that are created by aggregating the items into subscales or item parcels. So this model has been presented also by Eid and colleagues, and there are a number of papers in which this model has been discussed in detail. You can find the concrete references for those papers in the description here for this video. Now, if you want to learn more about multi-trait, multi-method analysis and CFA MTMM models, check out my QuantFish workshop on these types of methods, which you can also find in the description, and you can find a whole bunch of other resources there as well. So please check those out, and I hope I'll see you again next time on the QuantFish channel when it comes to our weekly statistics tutorials, and take care until then.